Now let's come to others. I know there are many other protocols. I picked one now for a bit more explanation, and that's SCTP, Stream Control Transmission Protocol. There are many more. Some had their hyped super duper time like RSVP in the context of integrated services. Some were pure experimental, some are proprietary, special purpose, some still live on in special implementations, some military implementations, some deep space exploration, etc., etc. We touched TCP, multipath TCP, quick UDP, and now a bit more about SCTP and not the others. Why? Okay, Stream Control Transmission Protocol. There are several reasons why touching this. One is SCTP contains many features that are now re-implemented in Quick. SCTP never made it to end system, so why discussing it? Well, it's used in standard in mobile communications. So it's a real protocol out there used for good reasons. So what are the problems with TCP? Remember, head of line blocking. So TCP for many purposes is too strict with the in-order delivery. Especially, remember, if we have one TCP stream and we transmit logically several substreams across this one TCP stream. TCP doesn't know anything about the meaning, semantics of any substreams. So if we lose data from one of these streams, remember, context of Quick, for example, part of one of the pictures, why waiting delivering the data for the other pictures? So that was our head of line blocking. And so this very strict view on in-order delivery is not appropriate also for some other applications, and one of this is signaling in communication systems. And SS7, the signaling system number 7, was the dominant signaling system in the classical telephone system. So signaling is used for transmitting the caller number, for example. So if you call someone, the system has to forward the caller number to set up the connection. Okay. So web browsing, we touched this already in the context of Quick. So TCP is not perfect. SCTP could solve the problem. We also had limitations if we have multi-homed host. Remember, so if you have connection to cellular network and the Wi-Fi network. And then we also, in the context of TCP, looked into SYN flooding. That's also a problem. So different problems. And SCTP, as you saw from the timeline, the discussion was around 2000, so more than 24 years ago. TCP solved this. TCP is reliable, connection-oriented, can transmit messages. You support multi-streams, multi-home. You can support heartbeats, for example, to tell that the other side is still alive but doesn't have to transport anything. We have a four-way handshake to avoid the problems of SYN flooding. It's TCP friendly when it comes to this fairness, but it's more resistant in face of these flooding attacks. Many RFC covering SCTP, 9260 is the most current one, specifying protocol, packet formats, etc. And there's a nice high-level introduction to SCTP. That's the 3286. And then there are some RFCs regarding security attacks. And as I said, SCTP is integrated into the 4G and 5G protocol stack. So if you have a mobile phone network and you have your base station, you have your mobile phone here, and the base station signals something to a unit that roughly said coordinates the mobility of the mobile phone. This communication between the E node B, as this is called, base station plus some controller, etc., E node B, and the MME, or in 5G speak, it's the 5G AN and the AMF, Advanced Mobility Function. That's not the important part. This is done using SCTP, as specified in these technical specifications. They are, by the way, all available on the web page 3GPP, the Third Generation Partnership Project, so www.3g.org, and you will find all these specifications. So it's integrated part here, so SCTP is really used in mobile phone networks all over the world. So what is the idea? Multi-streaming. Multi-streaming, so you set up what is here called an association, and inside the association you can have multiple streams, and those streams are independent when it comes to the delivery sequence. And if there's a loss in one stream, then only delivery in this stream is affected, but not in the others. Remember, quick? You see? Same ideas. And so this is quite good for web pages. So you can assign an object to a stream, and then, well, it's not necessary to sort the different objects only within one object. So if one doesn't go through, the others go through, and you have a better user experience. All the streams are subjected to a common flow and congestion control. Perfect. So you see, that's something really quick to go over from SCTP. Then we have two sequence numbers. There's a transmission sequence number. That's for the transmission of messages. That's the detection of message loss. And there's a sequence number for identification and inside a stream. So that's important for the sequence of received data. So the idea is separate the streams. So if one stream loses something, so what doesn't matter for the other side. So SCTP supports the multi-streaming. Those ideas were already there in 2000. Also multi-homing. So we have, as a single endpoint, single system, we can support multiple IP addresses. Okay, that sounds like multipath TCP. Yes, that's a similar idea. So we can use this for redundancy. And the initial idea was not for load sharing, but you see, these are similar ideas. So you could use this for redundancy, and you could use this for failover. So you could connect your laptop via a local area network and wireless LAN and UMTS and whatever to the internet. So that was the idea at that time, around 2000. Well, UMTS doesn't exist in many countries any longer, but so then we have LTE instead. So that was the idea. So failure of one network will not cause the failure of the association. So that is the idea. So you have one address, that's the primary IP address, and for normal transmission, that's the destination. And if you retransmit, you can use alternate addresses. And if you have continuous failure of the primary address, then you can use permanently for all the data alternate addresses until you re-establish the primary address. So that's just a very brief introduction, just to show you the ideas were already there for, in this case, multipath TCP or these multiple streams for QUIC. And it was SCTP. And SCTP sure has a certain header format, a common header, and after the common header with source port and destination port, very simple. As you see, source destination port, just the verification tag, so that's me, and the simple checksum. You see, much simpler compared to TCP, so that's more this UDP style. But remember, what's the problem? It's not UDP or TCP. So SCTP has to be supported in the end system, and problems with the middle boxes. And that's one of the reasons. It never made its way into Windows, for example, then you don't have on the end systems. We would have problems with the middle boxes, so you cannot use it. But in mobile phone networks, because there a network operator controls the whole network. So we don't have a problem if we use a complete different protocol, a better protocol. Then chunks, and this is also something that has been learned. So chunks, type, length, value. Classical setting for content. And former times it was also a bit more complex. So common header, this really is like this TCP UDP, a port, and you have verification. That's the idea, is that you validate the sender per association, and so that you know what you're talking to. So that's the idea, is that make it simple but verifiable. Yes, a checksum, 32-bit checksum, so much stronger compared to the checksums we have in UDP and in TCP, calculated over the whole SCTP packet, including the header, and if a packet is invalid, well, you typically silently discard them. As I said, just very brief overview showing you how the development of the protocol has been done. We learned, okay, checksum, we can do it better with these polynomials. You see it here. We know type length value, that's quite common. Okay, you see it here. The chunks have this type length value. So that's the idea here. We have different types like heartbeat packets, like abort, shutdown, or initiation packets, etc. So that's the idea. And we do not have, like in TCP, a SYN bit or an ACK bit, or these things. So we have different types, explicitly defined types, and we have a length, and we have the value, which is the content of the chunk. And then just a simple example. So a data chunk, as they're called, there you see the fields. You have a type is 0, and then some special bits we need here for data. So we can ignore stream sequence or unordered, or we can use the sequence number, and then we can indicate this is the first fragment, a middle fragment, last fragment of a message, etc. We have sequence numbers in here. We have stream identifiers so that we know where it belongs to, and so on. Stream sequence numbers so that we know inside the stream the order of the packet, and so on. And if we fragment it, all the fragments must carry the same stream sequence number, so we know, okay, that's the sequence number inside the stream, and an identifier for the payload. That's for the application layer protocol. That's used typically by the end system that we know where it belongs to. That was not to introduce completely SCTP. That was just to show you how the development continued from the initial parts of TCP. Then there were already the ideas, we have to do something new, and the ideas were there. Multiple streams, multiple endpoints, type length value, a bit more modern protocol design, but SCTP never made its way to the end systems. It was picked for mobile communications, but that's a real special case of a network. That's an internet IP-based network as well, so the TCP, UDP, etc. is used, but also SCTP, and here the special purpose for signaling, but never in the internet for all the end systems. There you will see QUIC, there will see multipath TCP, but not SCTP, for example, and not all the other transport layer protocols. Okay, let's summarize. So we all started with the TCP IP reference model. The TCP IP reference model, we know only two protocols, UDP and TCP. UDP, very simple, lightweight, unreliable. TCP, we know we have all this connection establishment, flow control, congestion control, etc., built in. But that led to the problem that, okay, everyone says these are the transport layer protocols, and this created this ossification. Because we said these are the transport layer protocols, we created also all the middle boxes and operating systems, everything based on this. So all the middle boxes assumed, oh yeah, these are the protocols, and I know how TCP works. And now you want to introduce something new. Well, looking at the timeline, first we had SCTP around 2000. SCTP had good ideas, multi-streaming, multi-homing, nice. Today used in LTE 5G networks internally, so to support signaling. Never made it really to other end systems. The problems TCP has with web pages remained. And this is why some of the SCTP ideas plus security, so TLS ideas, came together and Quick has been created. Quick, an example where industry, Google, pushed something because they said we have to deliver, especially web pages, much faster. Why was this possible? Because we use UDP at the core. So we don't have to change anything. We don't have to change really, let's say, the operating system, the interfaces, the middle boxes. For them, it's UDP. Yes, we have problems because UDP is not connection oriented, and so the middle boxes may behave strange when it comes to Quick. Then we can always fall back to TCP. And we saw this multi-homing creating multipath TCP. Why does it work? Because for the network, it looks like TCP. So basically, well, then we have the multipath part on top of it, but basically it looks like TCP. So, well, to be honest, we still have the ossification because we didn't really open up the transport platform for new protocols. We still said, okay, we will not really touch the UDP and the TCP. So we now use multiple TCP flows and bring them together in the end system. That's multipath TCP. And we use UDP and do something on top of that. That's Quick. With the problems with middle boxes still existing. But that's the way it has been done. Because otherwise, history shows with all the other protocols, they've never made their way, never took off. Reliable UDP, UDP Lite, using only partial checksums, DCCP, ossification. I mean, Quick uses UDP. Nice trick. And if you want to see, there are many other layer 4 protocols. Follow the link and you see that, oh, there is a bit more because the IP version 4 and 6, the protocol and next header, they will tell you what is the next layer 4 protocol. And there you will see many others. And you will see maybe for what they are used. But sure, you will not find Quick because Quick uses UDP. So go ahead, find out yourself more about additional transport layer protocols and the reason why they never took off. Sometimes political reasons, sometimes industry never used it, not invented here and all the other problems. SCTP, well, yes, started 2000, never really made it to end systems. Why? What was the problem? But it's used now. Why? And why could it be deployed there? So what are the advantages of this SCTP? What is the idea? In this context, what is the problem of deploying a new transport layer protocol? And so why choose Quick a certain trick? Which problems still remain, although we use this trick? Quick uses. I mean, now we still have problems. So now you know all the basics of all the layers, layer 1 up to 4. You know some application layer protocols. Now please take Wireshark, follow TCP connections, follow Quick, search for it, find out the typical header fields, look for example for retransmissions to get a better understanding of all these layers.